And here's a real quick overview of the calculations involved in converting from hydrogen ion concentration to hydroxide ion concentration, or to pH, or to pOH. If you have any one of those four things, you can calculate the other three. So, for a moment, let's just say you have the hydrogen ion concentration. You can take advantage of this relationship that multiplying the hydrogen ion concentration by the hydroxide ion concentration always gives you kW, or 1 times 10 to the negative 14. That's a relationship that's true for any solution occurring in water. So you could convert back and forth between these concentrations using that relationship, that if you know one, you can always calculate the other. Of course, we've been spending a bit of time saying that to calculate pH from hydrogen ion concentration, you calculate it by saying the negative log of the hydrogen ion concentration. We'll practice that in just a moment. Or if you had hydroxide ion concentration and what you needed to calculate was pOH, where pOH is simply a measurement of how concentrated the hydroxide ions in the solution, how concentrated they are, you can calculate that using the negative log of the hydroxide ion concentration. So that gives you some things you can calculate. One relationship that you're already familiar with as well is this relationship between pH and pOH, that if you add them together, you will get 14. So even if you're in a concentrated acid, for example, and the pH happens to be lower than 1, the pH plus the pOH will still add up to 14. Now, the relationship here, going from pH to hydrogen ion, is calculated by 10 raised to the power of the negative pH. And pOH can be calculated by taking 10 and raising it to the power of hydroxide, or the pOH. So here we see several examples of this. In this particular problem, we said, okay, the pH is 8.45. We calculated the pOH by showing this relationship. pOH is equal to 14 minus the pH. So the pH was calculated then as 5.55. We could also calculate the the hydrogen ion concentration is 10 raised to the negative pH. So that's 10 raised to negative 8.45. Remember, the pH up here originally 8.45. Here we're just changing the sign, negative 8.45. And then when you hit equals on your calculator, you should get this number. So if you can't enter 10 raised to the negative 8.45 and get 3.548 times 10 to the negative 9, you need to figure out what the problem is with the way you're using your calculator. Determine that error and you'll be home free, because these are really fairly easy problems. To calculate hydroxide ion concentration now, we have a couple of methods we could pick. We can use the relationship between the water dissociation constant, that is, that 1 times 10 to the negative 14 divided by the hydrogen ion concentration, is going to give us the hydroxide ion concentration. Or we can say 10 raised to the negative pOH will give us the hydroxide ion concentration. And it should come out the same either way. Well, there you go. Good luck on that.